Hello, sir. Am I audible?
Yes, you're audible.
Uh, so, sir, let me make you the host. Okay. 𝗵𝗯𝗃 Safan Ahmed. Who is this? Uh, please make me the host.
Hello, sir. Sir,
Hello.
good evening, sir.
Please make me the host.
सर व्हाट्सएप पे जो लिंक आया था
Mm-hmm.
तो उस पर क्लिक करा था गेट आईडी बोल के सीसीएनए के लिए।
नवाब, एक बार ना आप लेफ्ट होके फिर से ज्वाइन कर लेना। एक बार लेफ्ट हो जाओ।
Nawab, can you hear? Nawab Sheikh, can you hear us?
हाँ yes, sir.
So I think you can disconnect the session and try to join once again.
Okay, sir.
Yeah. Okay, I think Vishal sir is the host now.
Yes, sir. Let me make you the host.
Okay.
सर आप एक ही आईडी से है ना, ट्रेनर श्रीधर, आई थिंक वही
That's
है।
right. That's right. That is right.
Yes, sir. Now you are the host. Please make me the co-host.
Sure.
Thank
Okay.
you, sir.
Yep.
Okay. Now you can start, sir. Over to you.
All right. Thank you. Hello, everyone. Good evening. So this is Sridhar. First of all, let me talk about myself. This is Sridhar. I have been in the network switching, routing switching, wireless, SD-WAN, Palo Alto in this industry for about 15 to 16 years in the same industry. And I have training experience of about, let's say, 10 years, right? So this is my total experience. Yeah, and I'm an telecommunication engineering graduate. So I've been from my start, I've been in the networking industry. And I think most of you guys from here are also, they have crossed your CCNA and then come over to CCNP ENCOR. Or is there anyone who is, directly joined CCNP ENCOR? Is there anyone like that? All right, I think nobody. So that is about my introduction. Now, from this session, we will be discussing about CCNP ENCOR. Let me actually share my screen. Are you guys able to see my screen?
Yes, sir.
Right. So from this session onwards, we will be discussing about CCNP ENCOR. Now, we have, yes, the regular ritual is we will actually deal with the topics that we will be discussing. And also, at the start of every session, we will be going through the topics that we will be covering in that particular session. Now, for now, let me actually write down the syllabus. So I know I can get a, presentation where I can, show you the different syllabus, but maybe writing down somewhere helps you to somehow memorize or what are the units that we will be covering in CCNP ENCOR. The first part, please excuse my handwriting, guys. The first part that I will be dealing with is switching. The switching part deals with the switches and its connection to the routers on one side, maybe the hosts on the other side, the printers, the servers, etc. Right? Karan, could you mute yourself? Please don't mind. All right. Now, in the switching, we are going to deal with some concepts called as VLANs, trunks, access ports, right? We will be dealing with some protocols which are involved in switching. So you know that the basic protocol of switching, you would have gone through this protocol in your CCNA. You would have known this, and some concepts called as ether channel. All these we will be dealing in the switching portion. Now, coming back to Unit 2. It's all about, once we finish the switching, we will be dealing with routing. So it's very simple. Switches, when I say switching, it deals with the switches and some protocols which are involved with the switches. And what are the ports? What are the different types of ports that are involved in switches? And what are the functions? What are the configurations that we do on switching? That comes in the first unit. Routing covers most of the things that we do on the routers. What is a static route? What is a dynamic route? What are the different types of protocols that are involved in the routers so we can make or so we can exchange the information from one router to the other. All these we will be learning in the routing section. The third section involves something called as multicast. Now, you would have heard about what is multicast, what is unicast. So there are three different types of communication. One is unicast. Now, if I'm talking to one person in this group, it is known as unicast. Similarly, if one computer is talking to another computer, it is a unicast. Now, the second type of communication is broadcast. If I am shouting and everybody are able to listen to it, that is known as broadcast communication. The third type of communication is multicast, where I am talking only to a group of people. Let's say this CCNP batch, I'm only talking to you. The other CCNA batch is not able to hear it or know what I'm talking about. That is called as multicast communication. We will also learn how the multicast works in the network, right? The third unit is all about the multicast. Then we proceed with the network architecture. What is network architecture? So, how if I design my routers and switches, how if I connect my routers and switches, it is beneficial to my organization? How should my design be? Everything we are going to talk about in the network architecture portion. So just because you have routers and switches, you cannot take high-end routers. Let's say you have an organization of about where you need about 500 routers. you cannot plan all the routers to be high-end routers. Then it will be cost effective. You have to plan and design your network in such a way that I have to use high-end also, and also we can use a normal router also where it is feasible. And also, how should I plan my redundancy? Maybe let's say one device went down. How would I plan so to get a backup of that? That is all the things that are taught by our fourth unit, which is nothing but your network architecture. Moving on, we have some services, network services. We will be talking about services. Now, what are network services? You know about some protocols which provide services like DHCP, NAT. You would already know about what is NATing and what is an NTP protocol, what is QoS. These are the services that we can configure to our packets or to our network devices to get a benefit of them. In the fifth unit, we will be discussing about these services. And then moving on, we have assurance, nothing but network assurance. Now, what is network assurance? Am I sure that this router on the way is connected somewhere, or this host somewhere here is able to reach this router? Am I sure about this? It is called assurance. How do you make sure that yes, I have reachability? Yes, I have connectivity. Network assurance involves some of the protocols through which we can confirm the reachability or connectivity to different devices. It has some troubleshooting tools. It has some monitoring tools, right? Troubleshooting tools means you already know about some of them. Ping, traceroute, tracert. You would know about all these troubleshooting tools. And you have syslog, span, through which you will make sure that, yes, I have connectivity to some parts of the network. I don't have to worry about that, right? That is provided or that is learned in your unit called as network assurance. Then we move on talking about security. Now we know how the routers behave. Now we know how the switches behave. Now we know how the multicast behaves. Now we know how to, put them or design them, right? Now we know what are the services we can implement on our routers and switches. What are the policies we can apply? Now we know till where we have connectivity. Now we should care about security. Now, what if there is an attack, or what if a router is vulnerable? What if some traffic is illegitimate? It's not a legitimate traffic. What should I do? There comes your security. How to add security to your design, to your network devices, right? Then comes automation. We will be dealing with some of the automation stuff. Why do we need automation? What is the use of automation in network industry? Then comes virtualization. Right? How to virtualize the network. So for example, in nowadays, you would have known how to virtualize. So for example, how to make a router. Can I use a router only as a hardware device? No, we can use VMs. Inside a VM, we can make sure we will add a router image and act as a virtual machine. This starts behaving as a router or a switch or a server or a Palo Alto firewall, right? What does this virtualization teaches us? We will look at it in the last section of this syllabus. So this is the syllabus that we are going to be discussing. All these maybe for 2 months, 2.5 months. I'm not sure. But right away, I'm not assuring you the time. So let's say if we deal with the switching, if we deal with the routing, let's say you are taking some more time to understand routing or switching, we will spend more time here. If you are taking more time to understand multicast, we will spend more time here. There is no plan that we will finish in so and so. If you are understanding the basics well, if you are able to grab the concepts well, then yes, we will proceed with the topics as and when, as and when they are over, we will move to the next one. That's not a problem. So basically, there is no plan. It's a plan of like 2 months, I would say. But if it takes more time, it is still okay with me, right? So having said that, this is the syllabus that we have in front of us. Do you have any questions regarding this? Any questions regarding the syllabus or regarding anything or regarding me? Whatever you have, you can ask. Any doubts, any confusions? Okay, good. All right. So today would be the first session, or I would say today would be our first class of CCNP ENCOR. If you do not have anything to ask about the syllabus, about the timings, or regarding anything, we can move on to some of the technical parts today itself. Excuse me. All right. Moving on. Today, as we discussed the syllabus, we know that we are entering the first unit of CCNP ENCOR, and that unit relates, or that unit is all about switching. So everything regarding the switches, everything regarding the protocols that is related to switching, we will learn them in this part, in this section of CCNP ENCOR. Right? Now, when I talk about switching, you know that switch is a hardware, right? We know that why actually switch came into existence, because your computer just has 2 ports. I mean, 1 port. If I connect a cable from one computer to the other computer, the maximum that I can connect is 2 computers. Only 2 computers can be talking to each other, not more than that, right? Also, now if I say, why not have more ports on this? Then what is the function of this computer? The computer will be, see, nowadays, the computer is going more smaller and smaller. You have laptop, your tab, right? But if you have 100 ports on your computer, imagine, what is the function of the computer then? What does it do? Generating signals, generating packets, generating traffic. Instead of that, it has 100 ports. Then the hardware also should be big, right? So all they focused was on the centralized device that connects multiple devices. So switch was one of the centralized device which connected multiple devices. Now, having the switch as a centralized device, I can talk to anybody. I can talk to any number of computers based on the switch and its ports. If I take a switch of 48 ports, yes, then I can talk to 40 computers. If I take a switch of 8 ports, yes, I can talk to another six computers, because one of the ports will be connecting to router or whatever on the uplink, right? So basically, the switch was the centralized device, which actually connected more number of computers to it. Now, in the switch, if I wanted to segregate, so for example, I say on this switch, imagine your company environment, right? Your organization, if you're working on an organization, imagine that environment. Let's say in the first floor, you have a switch of 48 ports. For now, you just have these 8 users connected, out of which 2 belong to HR, or let's say 4 belong to HR, 2 belong to IT, 2 belong to BPO. Now, if I have all of them connected to the same switch, then definitely everybody will be getting that information, right? Whatever these guys send the information, everybody will be getting that information, right? Now, that's the reason we have something called as VLAN. Before moving to this VLAN, let me actually tell you how the switch behaves. Let me actually tell you how the switch behaves. You would have learned about the switch and the behavior of the switch in your CCNA. But just to make sure we are on the same path, I just want to, do a revision of your knowledge. Let's say there are some computers connected to your switches, right? Usually, you know that the computers will have a logical address and a physical address. A logical address, which is nothing but your IP address, and a physical address, which is nothing but your MAC address. Now, the MAC address is not just this. You know the MAC address, how it looks, right? You know the MAC address. It does not look this way. So MAC address may be similarly like this, 1EFAC13. It's a combination of alphabets and numbers. It's a 48-bit address. Just because I cannot write all of them here, I'm just taking just one part of it, right? We will come to MAC address. We will discuss what is MAC address. But if you already know it through CCNA, it is better, right? Now, let's say this computer wants to speak to any of the computers. We'll take this as port number 1. This is port number 2. This is port number 3. This is a switch. If there is anything going towards the switch, let's say this computer, PC1, wants to talk to PC2. Now, you know that whenever a system generates an information to another system, there comes an OSI model. Does everyone know about the OSI model? Is everyone familiar with the OSI model? Yes, no, maybe? Or you want me to reiterate? Okay. Now, let's say this PC has generated an information called as 101010. This is the information generated by the PC. Now, let's say I am the one, I'm writing a letter to any of you guys, right? This is Sridhar. Let's say this is somebody. Let's say J. Okay, this is J. If I just write a letter to J, will this letter reach J? No, right? it will not reach J. This letter will never go to J. So what should I do? I have to add an envelope, right? You know the envelope, right? Previously you guys have written letters and stuff. At least you would have heard about it. You add an envelope, right? On the envelope, you say from and you say two addresses. From address is me and this is J and his address. From address also involves name and my address. This is J and his address. Only then the letter would be able to reach J. Similarly, whenever the system generates any information, it should add something called as headers as per your OSI model. Now, what does your OSI model contain? Of course, everybody would be knowing it, but nobody is answering it. Maybe you're shy. It is application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. These are the different layers in the OSI model, Open System Interconnect. Right? In this, we have these many. What does the data link layer do? It adds a header. Source MAC address, destination MAC address, preamble, checksum, etc. Source MAC address and destination MAC address fields are found in data link layer. For now, I'm just holding on to source MAC and destination MAC. Network layer adds a header, source IP address, destination IP address. I'm just holding on to it, but there is many more things in the header. This has source port, destination port in the header. Similarly, if you see here, this PC who generated this information will add source MAC, which is AA, and destination MAC, which is BB. This is the layer 2 header. And also this PC will add layer 3 header. Layer 3 header is, what is the source IP? 1.1.1.1. Destination IP 1.1.1.2. This is a layer 3 header. For now, let's leave the layer 4 part, right? Let's leave the lower layer 4 part. Now, when it sends the data out of this computer to this switch, let's analyze how the switch behaves. Now, switch works on, let's talk about, instead of switch, this is you. Somebody hands over a letter to you. What will you do? Of course, you will check from whom is the letter coming and to whom this letter has to reach. Similarly, the switch will only check the layer 2 part of it. Reason being, the switch is a layer 2 device. It will check the layer 2 part of it. It will come to know that this is coming from AA and it wants to go to the destination BB. Now, always a switch maintains a MAC address table. There is a MAC address table which is maintained by the switches. Now, at first, the MAC address table will be empty. There will be nothing inside this MAC address table. As and when this traffic comes and hits this port number 1, it will see that who is coming and hitting on to my port number 1. Okay, there is somebody with the MAC address called AA. So it will write down in its MAC address table saying that port number 1 is connected to this guy called AA, who has the physical address AA. Then it checks where it wants to go. BB. Do I have an entry? Do I know where is BB? It will check its MAC address table. If a letter comes to you and you have nothing in your brain, what do you do? Of course, you don't know what to do, right? Similarly, when something comes to the switch and switch sees that I don't know where is BB, the normal behavior of the switch is to flood to every other port it has. Not only 2 and 3, if it has 4, 5, 6, whatever, it will flood to the information, same information to all the ports. So basically what you have to remember when it comes to the switches is, whenever switch does not know the information, or whenever switch does not know where it has to go, where the information has to go, it will flood the information to all the ports, right? Now let's say, whenever it floods the information to all the ports, what is it called as? What type of communication is that? I told you the communication is of 3 types: unicast, multicast, and broadcast. Now, whenever the switch floods the information to all the ports, what type of communication is that? All the ports. It doesn't care which port. It is flooding to all the ports. So that type of communication is called as broadcast. So basically, we can say that whenever the switch does not know any information, it will just broadcast it to all the ports. It will just broadcast it to all the ports except the port which it received it from. It will not send out from the same port. It will broadcast to all the ports. Now let's talk about the second scenario. Now let's say there is an information in the MAC address table. Now the switch will see what is the frame which is incoming to me. It is incoming on port number 1. Do I have an entry that port number 1 is receiving some information by the device which has MAC address of AA? Yes, I have an entry already. Where does it want to go? It wants to go to BB. Do I have an information in my table? This table is the brain of this switch. Do I have the information of this? Yes. BB is connected to port number 2. Then it will only send the information to port number 2. That is called as unicast communication. So when the switch knows in the MAC address table, when the switch knows where to forward this information, or it has an information of the destination MAC address, it will send a unicast. It will only unicast to the concerned port, the port which is mentioned here, right? And there is something called as broadcast address itself. Now this is BB. It is a physical address of some machine. It is a physical address of some machine. Now instead of BB, if I say all Fs, that is FF, 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 FF. These are called as all Fs. In the layer 2, this all Fs is called as broadcast address, right? It is called as broadcast address. Whenever there is an information coming from a computer to a broadcast address, again the switch will send it to all the ports, because it will identify this address as a broadcast address, and it will forward to everyone. Everyone in the sense, every port of the switch. Now, having said that, this table, MAC address table, is a dynamic table. Why I say it is a dynamic table? Because whenever the traffic is incoming to the switch, whenever the traffic comes in to the switch, based on the incoming traffic, the switch automatically builds this table. Now, if a frame is coming here to port number 1, it will see what is the source, who is sending it. It will map that particular port with that computer's physical address. So it is a dynamic table, dynamically generated table by the switch. Now, let's take the first scenario. Now, I have no information. This guy is coming here, and I saw this guy coming. Okay, he is coming to port number 1. So I said port number 1 is connected to this guy who has address A. Now, he wants to go to BB. Let's say he wants to go to BB. I don't have the information in my MAC address table. So what will I do? Any idea? Anybody? So what will the switch do if it does not have an information in the MAC address table?
It will broadcast, send a broadcast.
Exactly. Correct. It will send a broadcast to all the ports. Right? It will send a broadcast to all the ports. Now, when it sends a broadcast to all the ports, this guy, let's say this guy will receive this frame, PC3. He will see what is the layer 2 header. Layer 2 header is BB, which is not me. Layer 3 header, what is the destination of this layer 3 header? 1112, which is again not me. So he will discard this frame. He will discard this information. Now, other information which is broadcasted, it is going to PC number 2. This guy will say, yes, layer 2 destination address is BB, which is me. Layer 3 destination address, again it is me. So this frame is for me. He will process this data. He will process this data. Then, once he wants to send a reply, now once he processes this data, he will also plan to reply to the sender, right? He wants to reply to the sender. Now, the packet went here and here, both. And this guy discarded because it was not for him. He could see the address, he could read the address. Now, PC can read all the layers, layer 1, 2, 3, whatever the header is, layer 1 header, layer 2 header, layer 3 header, layer 4 header. PC3 can read all the headers, but switch, it's a layer 2 device. It can only read the layer 2 part. You should know that. Okay. Now, the information went here and went here. And PC2 agreed. PC2 processed the information, PC3 discarded the information. Now, PC2 wants to reply to PC1. So, who is the sender now? Who is the sender? Who is the receiver? Let's write down only layer 3 header. Okay, let's say first, let's say PC2 wants to reply something, and the reply data is 01010100. Now, he wants to add layer 2 header to it. What is the source of the layer 2 header? What is the source MAC address? Source MAC address is nothing but BB. Do you agree? Because this guy is the sender now. So he is the source MAC address. BB is the source MAC address. And what is the destination MAC address? To my sender who sent me the packet previously. So this guy, I saw his MAC address from the incoming packet. So he is the sender. And what is the source IP address? This one, do you agree? 1112 is the source IP address because this guy is now replying to him. What is the destination IP address? This guy. Now I will send this packet out of my computer and it goes to the switch. Again, the switch will see there is something coming to my port number 2. So port number 2, who is sending this information? Of course, source MAC address. Whoever is in the source MAC address field, that guy will be sending that information. So it will fill the information. Now he'll check. The switch will check where does he want to go to. What is the destination? Destination is AA. Let me check again in my MAC address table. Okay, AA is connected to port number 1. So he will forward only to port number 1. Right? The information coming out of port number 1 will reach the PC1. This is how the switches automatically update the MAC address tables. Right? They update the MAC address tables. Now, you might also ask me, sir, does PC1 and PC2 or PC3, they don't have any tables? Yes, they also have some tables. They also have some tables. It is known as ARP table. Here also it is an ARP table. What do you find in the ARP table? This guy knows only his MAC address 1.1.1.2 and my MAC address is BB. But whenever a packet comes from this guy to this guy, from PC1 to PC2, this PC will make sure that, okay, PC1 has a IP address of 1111 and his MAC address is AA. Let me note down that. This is the ARP table of your PC2. And this guy, whenever he sees this reply, he will make sure first he will have only his IP address with his own MAC address. Then whenever a reply comes from PC2, he will have the PC2 IP address with the PC2 MAC address. That is also dynamically generated address. So for example, if you want to verify that, you can also verify it in your own PC, right? So let's go to CMD. If I want to see my ARP table, I'll say ARP-A. These are the IP addresses. See, this is my gateway, Wi-Fi router gateway, and the MAC address of it. So MAC address of the Wi-Fi router and my IP address is IP config. My IP address is 192.168.0.30 and 0.1 is my gateway. Right? Now, what is an ARP table? It is a table which has a mapping of MAC address to IP address. And this ARP table is maintained by all the devices to which we assign IP address. So if on any device, if you are able to assign IP address to it, that device will start maintaining the ARP table. If that device has no IP address configured on it, then there is no ARP table. So the devices which are capable of being assigned with IP address, those devices maintain ARP table. Computers, switches. So let's say switches. There is no IP address on switch now. But if I configure one, it will start maintaining ARP table. right? Now, what is a MAC address? MAC address is nothing but the mapping of port numbers to MAC addresses. It is a mapping of port numbers to MAC addresses. And MAC address table is maintained only by the layer 2 devices, because that is the brain for them. Based on the brain, they actually behave. If there is no MAC address, if there is no entry in this table, they just broadcast. They just broadcast. Does this make sense? Yeah, sure. Go ahead.
If the switches already have a MAC address table, and I later on I change the one of the PC, for example, I change the PCB with a PCD, then what will happen?
Exactly. Good question. So let's say now this guy is having BB, this guy is having CC. Let's say there is entry for CC as well. Now this is BB. Now port number 3 is connected to CC. The switch knows this. Now whenever this guy is connected, right? Whenever he sends any traffic, of course his layer 2, let's say his traffic is 1010. His layer 2 header is source is CC, destination is BB, then his source IP is 1113, destination is 1112. When this hits the switch will come to know that on port number 3, I'm getting a different MAC address, CC. Or let's say he's changed to DD. The switch will come to know that, okay, now port number 3 is not connected to CC, but he is connected to, it is not CC here anymore, it is connected to DD. And also, this dynamic table expires, right? So there is an expiry time for this because of the same thing that you told. The computers keep changing on every port. You're not sure that this port will be occupied by the same system all the time. So this table also has an expiry time, right? It has, let's say, it has around 15 minutes, if I'm not sure. It is 15, 20 minutes or 2 minutes. I'm not sure. I have to check that. But always the dynamic tables, right? The dynamic tables which are created by the switches, right? They will definitely have an expiry. Even the ARP table for that instance, it will definitely have an expiry. Okay, this is for 5 minutes. 5 minutes. That is 300 seconds. Every 300 seconds, this will get renewed. It will wait for a traffic to come, then it will learn again. And also, nowadays what is happening is, whenever you connect any device, that device automatically updates to the neighboring device saying that this is my port and this is my MAC address. Automatically it updates. We don't have to wait for the traffic at all. As and when you connect a device to this port, the device automatically updates the neighboring device saying that this is so and so my traffic, so and so IP address, whatever. This is the device. I am capable of so and so functions. Everything it will update to the neighboring device. Does that make sense?
Yes, sir. Thank you.
Right. So that is about the behavior of switches, which we saw today. Before to switches, we had bridge and hub. Their only function was, we had a hub whose only function was broadcast whatever comes, just broadcast it to all the ports. We had something called as hubs before to switches. They stopped using hubs now. Because let's say this is the computer, this is a computer, right? In a hub is acting as a centralized device. Let's say this PC1 with IP address of 1.1.1.1, PC2, which is having 1112, PC3, 1113. Whenever something used to come to the hub, it used to broadcast to everyone. So what is the problem? The problem is, let's say this guy sent something. Hub is sending to this guy, this guy, this guy. But in the same time, this guy wants to speak something to this guy. But what is happening? These wires are already occupied by this guy's broadcast. These wires are already occupied. Imagine a water flowing. The water will be sent out of this pipe also, this pipe also, this pipe also. Now, if this guy wants to send some water to this from here to here, his pipe is already full. So the bandwidth will be eaten up. With more broadcast, what happens? The bandwidth will be eaten up. There will be no space. That is the reason they wanted to change this device. I don't want a device which will always broadcast to everyone. Only if it does not know anything, let it broadcast. If it knows, it has to send it to only that guy. Then came the invention of something called as a switch. Right, so I think that's enough for today. We will have a more deep discussion from tomorrow. This was just an introductory class that we had. So, but yeah, in the next class, I would still want to know what what type of is it been long that you guys have done CCNA, or have you completed your CCNA just a few months ago or days ago? So it would be very helpful. So because in CCNA, you would have already gone through all this, the behavior of switches, the behavior of routers, you would have gone through all of this. So if I assume that you're already done CCNA and skip all these parts and move ahead, then maybe the learning would be restricted for you guys. Some of the concepts would be still a confusion for you guys. So it is better that you guys, let me know that, if you want these, basic concepts also, or do you know them already through CCNA? You can let me know. It is not a problem to go over them again.
For me, I did CCNA 15 years back, and
Okay.
I didn't work on a network. So I was completely working on a different domain. I now slowly moving back to the network domain. So that's why.
Understood. Got you. So I think basic concepts make some sense to you. Now you would need some basic concepts. That's what you're trying to say, right?
Yeah, I would prefer that.
Yeah. Okay.
Just to refresh. Yeah.
Got it. All right. That's good. All right. So that's pretty much it, what I had today. So we will start from tomorrow. Again, we'll connect at the same time. So this would be Monday, Tuesday, Wednesday, and Thursday. Friday would not be, we would not have any class, as I have some implementations on Friday. Monday to Thursday would be regular class at the same time that you joined today. If you have any questions, you can ask me. If you do not have any questions, then we can wind it up. Okay, I'll take that as no questions. So we'll wind it up for the day. Thank you, guys. Thanks for your time. Thanks for joining in. Have a good rest of the day. Thank you, Vishal sir. Thank you.
Thank you so much, sir. Thank you, everyone.
Thank you.